Hello everyone. In previous lecture, chapter 5 was completed, and in this lecture we are going to start chapter 5, and the name of this chapter is Permeability and Seepage. In this chapter basically we will discuss the different methods of determining the permeability of soils and also the study of various factors which affect the permeability and seepage of soil. This is the outline of this chapter. Then permeability. Permeability is defined as the property of a porous material which permits the passage or seepage of water or any other fluids through its interconnecting voids. A material having continuous voids is called permeable. For example, gravels are highly permeable while stiff clay is the least permeable, and hence such a clay may be termed impermeable for all practical purposes. Importance of permeability. The knowledge of permeability is very much essential in a number of soil engineering problems. To solve different problems, it is necessary to know the details about the permeability of soil. For example, to know about the settlement of buildings, yield of wells, seepage through and below the earth surface. Also, permeability controls the hydraulic stability of soil masses. And the permeability of soils is also required in the design of filters required to prevent piping in hydraulic structures. So that the knowledge of permeability is very much important. Next, Darcys Law. The law of flow of water through soil was first studied by Darcy in 1856, who demonstrated experimentally that for laminar flow conditions in a saturated soil, the rate of flow or the discharge per unit time is proportional to the hydraulic gradient. And he experimentally found that for laminar flow in a homogeneous soil, the velocity of flow V is given by V equal to K into I. We give it equation 1 where K equal to coefficient of permeability, I equal to hydraulic gradient, V equal to velocity of flow in laminar flow in homogeneous soil. Already I have told about it. The above equation is known as Darcys Law, which is one of the cornerstones of soil engineering. And the discharge small q is obtained by multiplying the velocity of flow V by the total cross-sectional area capital A normal to the direction of flow, and we represented this like this. Thus q equal to V into A equal to, in place of V we can write K into I as it is written in equation 1. So q equal to K into I into A, give it equation 2. So this is a formula you have to remember, also the Darcys law. So the velocity of flow is also known as discharge velocity or superficial velocity, and the area capital A in the above equation includes both the solids and the voids, the total area of soil. Next is coefficient of permeability, K. So coefficient of permeability can be defined using the equation 1, V equal to Ki we know, so that K equal to V by I. If the hydraulic gradient is unity or its value is 1, then K equal to V. If we put the value of I equal to 1, then obviously K equal to V. This is K equal to V. The coefficient of permeability is defined as the velocity of flow which would occur under unit hydraulic gradient. And the coefficient of permeability is equal to the velocity of flow. It has the dimensions same as the velocity. So its dimension or its unit is millimeter per second, centimeter per second, meter per second, or meter per day, or other velocity units. And the coefficient of permeability depends upon the particle size and upon many factors. So, let us discuss what are the factors which affect the permeability of soil. Some factors, major factors are particle size, structure of soil mass, shape of particles, void ratio, properties of water, degree of saturation, water, impurities in water. So these are the main factors which affect the permeability of soil. Let us discuss one by one briefly. So first one is particle size. So the coefficient of permeability of soil is proportional to the square of particle size. If we consider the particle size is d, then the coefficient of permeability is proportional to the square of this size. And the permeability varies approximately as the square of the grain size, since soils consist of many different sized grains. Some specific grain size has to be used for comparison. And the permeability of coarse grained soils is very large as compared to that of fine grained soils. So the permeability of coarse sand may be more than 1 million times as much that of clay. So we can also write the formula K equal to C into D square, D10 square. D10 is the effective size, we know, effective diameter D10. And C is the constant approximately equal to 100 when D10 is expressed in centimeter. So we can also write this formula here, K equal to C into D10 square. Next is the structure of soil mass. So the K takes into an account the shape of flow passes. The size of flow passes depends upon the structural arrangement of soil. And for same void ratio, the permeability is more in the case of flocculated structure as compared to that in the dispersed structure. And for stratified soil, deposits have greater permeability parallel to the plane of stratification than that perpendicular to this plane. And the structural arrangement of the particle may vary at the same void ratio depending upon the method of deposition or compacting the soil mass. The structure may be entirely different for a disturbed sample as compared to an undisturbed sample, which may possess stratification. So when flow through natural soil deposits is under consideration, permeability should be determined on undisturbed soil as its natural structural arrangement. Next is shape of particles. So the permeability of a soil also depends upon the different shape of the particles of soil. Angular particles have greater specific surface as compared with the rounded particles. However, in a natural deposit, the void ratio for a soil with angular particles may be greater than that for rounded particles, and the soil with angular particles may be actually more permeable. As shown here, this is an example of type of soil, rounded and angular, it is shown here. Number 4, void ratio. So for a given soil, the greater the void ratio, the higher is the value of the coefficient of permeability. Obviously, if the void is more, then ultimately the permeability of soil also more. So based on the other concepts, it has been established that the permeability of soil varies as E square or E square by 1 plus E. Next is properties of water. So, the coefficient of permeability is directly proportional to the unit weight of water, that is gamma W, and inversely proportional to its viscosity. And also the K increases with an increase the temperature due to reduction in the viscosity. Next is degree of saturation. If the soil is not fully saturated, it contains air pocket formed due to entrapped air or due to air liberated from percolating water. So whatever may be the cause of presence of air in the soils, the permeability is reduced due to presence of air, which causes blockage of faces. So if all the voids of soils are filled with air, that means there is no path for water to flow through it. So the permeability decreases. So consequently, the permeability of partially saturated soil is considerably smaller than that of a fully saturated soil. In fact, Darcys law is not strictly applicable to such soils. Next is adsorbed water. The adsorbed water surrounding the fine soil particles is not free to move and reduces the effective pore space available for the passage of water. So it causes an obstruction to flow of water in the pores and hence reduces the permeability of soils. In some cases, at very low hydraulic gradient, the K value of fine grained soils becomes negligible small due to presence of adsorbed water. Next is impurities in water, or whatever the foreign matters which are present in the water. Any foreign matter in water has a tendency to plug or to blockage the flow of water through it and reduces the effective voids, and hence the permeability of soil also reduces. So these are the main factors which are mostly affect the permeability of soils. So for this lecture this much. In next lecture again we proceed with another concept. This is hydraulic gradient. Thank you.